You are listening to Pankaj Rai, and in this series of videos we will be discussing the IUPAC nomenclature of carbon compounds, starting with alkanes followed by alkenes, alkynes, alcohols, aldehydes, carboxylic acids, ketones and haloalkanes. So let us begin our discussion with alkanes. For that, let us start from the basic, which is carbon. Carbon, as we all know, has atomic number 6 and it is having 2 electrons in the innermost shell and 4 electrons in the outermost shell. Let's say this is the nucleus of carbon. Then the first orbit is having 2 electrons and the second orbit is having 4 electrons. Now carbon can be represented as like this as well, stating that there are 4 electrons in the outermost orbit. To attain stability, that is to attain octet, the carbon needs 4 electrons more in the outermost shell. Let us also discuss about hydrogen. Hydrogen, as we all know, has atomic number 1 and its configuration is 1 only, having 1 electron in the innermost shell. Let's say this is the nucleus of hydrogen and the first orbit is having only 1 electron. Let's say we represent hydrogen like this, stating that there is 1 electron in the outermost shell of the hydrogen and it requires 1 more electron to complete its stability, that is the duplet. Let us move ahead. Let's say there is a carbon having 4 electrons in its outermost shell. It requires 4 more electrons to complete its octet and achieve stability. Let's say there is a hydrogen having 1 electron, and let's say the carbon and hydrogen decides to share 1 electron each. So carbon would be sharing this electron with hydrogen and hydrogen would be sharing this electron with carbon. There will be a formation of a bond and this bond is called as covalent bond. That is the bond formed by sharing of electrons. As you can see here, now the hydrogen is having 2 electrons, one its own and one which has been shared by carbon. So hydrogen here is stable with its duplet, but carbon still has only 5 electrons in its outermost shell, the 4 which it was having and 1 which is shared by hydrogen. So carbon needs 3 more electrons to complete its octet. Let's say there is one more hydrogen having an electron and let's say they are sharing again in the same manner. So here the hydrogen will have 2 electrons and it will be stable, whereas the carbon now has 6 electrons, 4 its own and 2 which is shared by the hydrogen. It needs 2 more electrons. Let's say there is one more hydrogen sharing 1 more electron with the carbon. So now this hydrogen has achieved its stability by having 2 electrons, one its own and one shared by the carbon, so it is stable, but carbon still have 1 more electrons to go, that is it needs 1 more electrons to complete its stability. Let's say there is one more hydrogen having 1 electron and let's say this carbon and this hydrogen decides to share these electrons. Now this hydrogen has achieved stability because it has got 2 electrons, one its own and one by the carbon. And now eventually carbon has also attained stability because now it is having 8 electrons in its outermost shell, 4 its own and 4 shared by the 4 hydrogens. So carbon is stable as well. As you can see, there is formation of 4 bonds. That is, a carbon is forming 4 bonds with 4 hydrogens. So this is the structural form of this compound and this is written as CH4, which is called as methane. Let us move ahead. Let's say there are 2 carbon atoms. This is the first carbon atom and there is one more carbon atom beside it. And let's say these two carbon atoms share one electron each between them. That is, let's say they start sharing these two electrons. So now both the carbons are having 5 electrons. Let's say this carbon, which was having 4 electrons of its own, it is having one more electron which is shared by the second carbon, so it is having 5 electrons in each. And this carbon, which was having 4 electrons of its own, and there is one more electron shared by the first carbon, so now it is having 5 electrons. So both the carbons need 3 more electrons to complete their octet. Let's say again hydrogen forms a bond here in the same manner as we have discussed earlier. One more hydrogen forming a bond over here. One more hydrogen forming a bond over here. As you can see, the leftmost carbon, the first carbon, is stable now, having 4 electrons of its own, 3 electrons from the 3 hydrogens and 1 electron from the neighboring carbon. In the similar way, let's say we stabilize the second carbon atom as well, with the 3 hydrogens sharing 3 electrons. Now as you can see, all the hydrogen atoms are stable and the carbon atoms are also stable. This carbon has also achieved its octet. So all the atoms in this molecule or in this compound are stable. The structure would be like the carbon is forming a bond with the other carbon, and this carbon is forming 3 bonds with 3 hydrogens. This carbon as well is forming 3 bonds with 3 hydrogens. The molecule or the compound would be written as CH3, this one, and bonded with CH3, this part, and it is called as ethane. In this manner we can keep going with our discussion. Let us see what happens next. Now let us take 3 carbon atoms. Let's say one carbon atom bonded with another carbon atom bonded with one more carbon atom. Now this carbon atom is bonded with this one, so it will have 3 more bonds to form, because each carbon can form 4 bonds. Remember that. This carbon atom has already formed 2 bonds, one with this carbon atom, one with this carbon atom, so it can form only 2 more bonds with 2 hydrogens. This carbon atom has formed 1 bond with this carbon atom, so it can form 3 more bonds with hydrogens. So this is our next compound, which is CH3 bonded with CH2 bonded with CH3. It is propane. In the similar manner we can go ahead. Let's say there is a chain of 4 carbon atoms. Now this carbon atom has already formed 1 bond, so it can form 3 more bonds. This carbon atom has already formed 2 bonds, so it can form 2 more bonds. This carbon atom has already formed 2 bonds, so it can form 2 more bonds. This carbon atom has formed only 1 bond, so it can form 3 bonds with hydrogens. So this straight chain compound of 4 carbon atoms would be written as CH3, CH2, CH2, CH3, and it will be called as butane. Let me tell you the example of 5 carbon atoms. Now let me tell this in another way. Let's say that as you can see here, this carbon atom, the center carbon atoms have bonds with 2 carbon atoms on each side. Okay, so this carbon atom has bonds with 2 neighboring carbon atoms, so it can form only 2 more bonds. This carbon atom already has 2 bonds with the left and the rightmost carbon, so it can form 2 more bonds. This carbon atom has formed 2 bonds with the left and the right carbon, so it can form 2 more bonds. Let's say this carbon atom which has formed 1 bond with this carbon, so it can form 3 more bonds, but as of now let's say we write only 2 more bonds. This one as well, let us write only 2 more bonds. As you can see that all the carbon atoms have at least 2 hydrogens bonded with them. Each one of them has at least 2 hydrogens bonded with them. Okay, but the extreme-most carbon atoms have one more extra bond with one more hydrogen. So can I say if there are 4, or let's say there are 5, there are 5 carbon atoms here, so each forming at least 2 bonds with hydrogen, so there are 5 hydrogen here and 5 hydrogen here, that is 10 hydrogens plus 1 and 1 hydrogen extra. What I'm saying is, let's say there were n carbon atoms, so at least there will be double number of hydrogens there, which will be H2n, and 1 extra on the extreme side, that is extra 2. So this is a formula for alkanes, which is CnH2n plus 2, meaning that if there are n carbon atoms, then there will be 2n hydrogen atoms at least plus 2 extra hydrogen atoms on the extreme side. This molecule as of now will be CH3, CH2, CH2, CH2 and CH3. It will be the pentane. As you can see in this as well, that there are 2 hydrogens bonded with each carbon at the center, and there are 2 hydrogens here as well with 1 extra, so that is making it 3. So if there are 5 carbon atoms, then there will be at least 10 hydrogen atoms plus 1 extra on the left side and 1 extra on the right side, so 2 extra. So the formula is CnH2n plus 2. That is a general formula for alkanes. Now the 6 carbon compound is called as hexane, 7 is heptane, 8 is octane, 9 is nonane, and 10, the final one, is decane. So in this way we complete the IUPAC nomenclature of alkanes. Thank you very much.